In this introduction to thermal effects, we consider that if we take this bar, this rectangular bar, go down at the tiny little level and increase the temperature, that at this tiny little level, this little square that's represented, that then let's say that we raise the temperature, then of course we all know that things are going to expand when we increase their temperature. And so there's a attempt to draw a concentric square that's sort of expanding. Now for the whole member itself, because usually members are not square, they have of course a long direction and a short direction, then this new expansion here is supposed to indicate that we'll have more of a buildup of deformations or expansion in the long direction than we do in the short direction. And of course we're going to capture this first at the tiny little level with the thermal strain being equal to the coefficient of thermal expansion times the change in temperature. Okay, and usually we're using alpha. Sometimes it's given the symbol alpha sub t for this coefficient of thermal expansion. You may have encountered this in a basic physics class before. And of course it's not just expansion. Usually the expansion and contraction coefficient are the same, so we just call it just usually coefficient of thermal expansion, and it's usually understood that it's also for contraction. The units associated with this will be units ultimately of strain over Fahrenheit degree or strain over Celsius degree. Right? And the physicist would be very careful to note the difference between Fahrenheit degree and degree Fahrenheit. For instance, delta T equal to 100 Fahrenheit degrees is a change in the temperature by, in this case, a plus 100 degrees in the Fahrenheit system, as opposed to a temperature of 100 degrees Fahrenheit is a specific temperature. So that in itself is maybe for many engineers not a very important thing, but to the physicist is as strikingly different as to use units in SI and all of a sudden start talking about units that are in the English system without having made any distinction or correct distinction in the units, or for instance confusing the difference between mass and weight would be just as a glaring error to them as degrees Fahrenheit and Fahrenheit degrees.